Hello everyone, hope you guys are doing well. In this video, we will go through 20 sample questions and answer them in detail to help you prepare for the AWS Certified Solutions Architect Associate exam. In case if you like to purchase the entire set of practice questions, use the link in the description below. I request you to comment if you would like me to do this sample test for any other AWS certification, and do subscribe, share and like the video. Let's get started. Your team develops a new online gaming application in EC2. The application will have a large number of users globally. For a great user experience, this application requires very low network latency and jitter. If the network speed is not fast enough, they will lose customers. Which tool would you choose to improve the application performance? Select any two. First, let's understand what is jitter. Jitter is the variation in time between each arriving data packet, generally caused by network congestion. For a great user experience, we need to have both the latency and the jitter as low as possible. AWS VPN links on-premises networks with AWS network. It doesn't really improve network performance. AWS Direct Connect is similar to VPN, but instead of using the internet to connect on-premises network with AWS VPC, it uses a dedicated private network connection, so it's incorrect too. API Gateway helps developers to create RESTful APIs, again not related to network latency. So the remaining ones are AWS Global Accelerator and CloudFront. Normally, your end users will travel multiple networks before reaching your application, affected by the latency and the performance of each network. AWS Global Accelerator solves this problem by moving the user's traffic onto the AWS global network more quickly. So option B is one of the right answers. And Amazon CloudFront speeds up the distribution of your content through a wide network of data centers called the edge locations. When a user requests a content, the user is routed to the edge location that provides the lowest latency. So option E is the other right answer. A company has a media processing application in their data center. Its file storage is built on a Windows file server. The application and the file server need to be migrated to AWS. You have to set up the file server in AWS, and the application code should continue working to access the file systems. Which method would you choose to create the file server? Since a Windows file server is required in this question, Amazon FSx for Windows File Server is the right answer, as it has native support for Windows file system features and is easy to lift and shift applications to AWS. Option A is incorrect, as Amazon Workspaces configures a desktop server which is not required in this question. Only a Windows file server is needed. Option B is incorrect, as EFS is for creating an NFS file system for use with AWS and on-premises resources. Option D is incorrect, as Amazon WorkDocs is a file sharing service in AWS. It doesn't provide a native Windows file system in cloud. You develop an application using AWS SDK to get objects from AWS S3. The objects are huge in size, and sometimes there are failures, especially when the network connection is poor. So you want to get a specific range of bytes in a single GET request and retrieve the whole object in parts. Which method can achieve this? Well, you can get objects from Amazon S3 by one of the following methods. Either retrieve an entire object with a single GET operation, or retrieve the object in parts by using the range HTTP header in a GET request. Getting only the specific parts of the object is useful when you are low on network bandwidth. So the correct answer is option B. Option A is incorrect because the question asks for multi-part download rather than multi-part upload. Option C is incorrect because adjusting retry request and timeouts cannot download specific parts of an object. Option D is incorrect as it suggests completely contrary to what's asked in the question. You have an application hosted in an auto-scaling group and an application load balancer distributes traffic to the auto-scaling group. You want to add a scaling policy that keeps the average aggregate CPU utilization of the auto-scaling group to be 60%. The capacity of the autoscaling group should increase or decrease based on this target value. Which scaling policy should you use? Well, there are several scaling policies for Amazon EC2, and first let's understand the differences between them. There is the simple scaling policy where you would specify a threshold for a metric and what happens if the threshold is breached. In this example, if the threshold is beyond 80% of CPU utilization, we add 2 instances. Well, one disadvantage with simple scaling is that once the scaling activity begins, the policy must wait for the activity to complete and the cooldown period to end before responding to additional alarms. So we have step scaling which can respond to multiple actions depending on the size of the alarm breach. So the policy can continue to respond to additional alarms even in the middle of a scaling event. In this example, nothing happens when the CPU utilization is between 40 and 60%. When the CPU utilization is greater than 60% and less than 80%, one instance is added. And when the utilization suddenly goes beyond 80%, 3 more instances are added. Since there is no cooling period after any scaling event, step scaling allows you to respond to sudden spikes in traffic. The next is target tracking scaling policy. Here, you don't make any decisions about how many instances to add or remove in response to a traffic. Rather, you just pick a metric, here it is CPU utilization, and set a value to be maintained. Autoscaling will automatically decide how many instances to add or remove so that the target is achieved. In this example, you have set a target CPU utilization to achieve. As traffic increases, the CPU utilization increases and goes beyond the target value. Autoscaling kicks in to add a few instances to bring the CPU utilization to its target value. And that's the right answer as well, since we need to maintain the CPU utilization of the group at 60%. With schedule scaling policy, you can set your own schedule. For example, if you see a spike in traffic on weekends, you can set a start and end time for EC2 instances to auto-scale during those periods. You launch a number of EC2 instances to run Cassandra. There are large distributed and replicated workloads in Cassandra, and you launch instances with EC2 placement groups. The traffic should be distributed evenly across several partitions, and each partition should contain multiple instances. Which strategy would you use when launching the placement groups? Well, first it is important to know that there are 3 placement strategies when using placement groups. They are cluster placement group, partition placement groups, and spread placement groups. The requirement in the question is to distribute the traffic evenly across several partitions, and each partition should contain several instances. Partition placement group is the suitable choice as you have multiple partitions and multiple instances within each partition. Amazon EC2 ensures that each partition within a placement group has its own set of racks, so each rack has its own network and power source, so effectively isolating the impact of hardware failure of any single partition. Furthermore, partition placement is useful for distributed and replicated workloads like Cassandra, which makes it the suitable choice. Cluster placement strategy puts all instances together in an availability zone, doesn't segregate them into different partitions, so it's incorrect. Spread placement strategy puts each instance in a different rack. It does not group instances in a partition, so it's incorrect. Option D is incorrect because there is nothing like network placement strategy. To improve network performance, you launch a C5EC2 Amazon Linux instance and enable enhanced networking by modifying the instance with this command and using the ENA support attribute. Which mechanism does the EC2 instance use to enhance the networking capabilities? This seems to be an easy question. Since the attribute used is ENA support, it will use Elastic Network Adapter or ENA to enhance the networking capabilities. As you can see here, networking capabilities can be enhanced with two mechanisms, either ENA or Intel Virtual Function Interface. To enable enhanced networking with Intel VF, you don't use this attribute, so it's incorrect, and all other options are not relevant. You deploy a Dockerized application in an AWS ECS cluster. As the application gets configuration files from an S3 bucket, the ECS containers should have the Amazon S3 read-only access permission. What is the correct method to configure the IAM permission? You must already be knowing that a policy is an object that defines a list of permissions. You can attach the policy to a user or a role, and when attached, the identity assumes all the access permissions defined in the AWS policy. Well, the correct way to configure IAM permission would be to attach the policy to the ECS container instance role. After the policy is attached to the IAM role, the ECS instances can use the role to get objects from S3. So option D is the right answer. Option A is incorrect because ECS cluster uses the container instance IAM role instead of environment variables to control its permissions. Option B is incorrect because the IAM entity that creates the ECS cluster does not pass its permissions to the ECS cluster. You need to configure an IAM role and attach it to the ECS cluster. Option C is incorrect. This is not the correct way to configure IAM permissions for an ECS cluster. You have an ECS instance in the US East 1 region. The application in the instance needs to access a DynamoDB table that is located in the US East 2 region. The connection must be private without leaving the Amazon network, and the instance should not use any public IP for communication. How would you configure this? For private connections between two VPCs in different regions, VPC peering is the best solution. But VPC peering alone isn't sufficient to let your application access DynamoDB tables. You need VPC endpoint as well, which creates a private connection between a VPC to supported AWS services like S3 and DynamoDB. Traffic between VPC and AWS service does not leave the Amazon network. The VPC endpoint allows users to privately access the DynamoDB service. So option B is the right answer. Option A is incorrect because you cannot configure an inter-region VPC endpoint directly. Option C is incorrect as it does not mention the usage of VPC endpoint. Option D is incorrect because VPC peering does support inter-region connections. You configure an S3 bucket as the origin for a new CloudFront distribution. You need to restrict access so that users cannot view the files by directly using the S3 URLs. The files should be fetched only through the CloudFront URL. Which method is the most appropriate? Well, if users access your files directly in S3, then they bypass the controls provided by the CloudFront signed URLs, so your protections no longer work. This is one of the reasons why you need to restrict access to S3 URLs once the S3 buckets are set up for CloudFront distribution. To ensure that your users access files only using the CloudFront URLs, there are two steps you need to do. First, create an origin access identity, which is a special CloudFront user, and associate this identity with your distribution. When your users access Amazon S3 files through CloudFront, the CloudFront origin access identity gets the files on behalf of your users. Second is to modify the permissions on your S3 bucket so that only the origin access identity can read the files. This makes sure that if your users request files directly by using S3 URLs, they are denied access. So option C is the right choice. Option A is incorrect because signed URLs are used to restrict access to files in CloudFront Edge cache. It cannot prevent users from fetching files directly through S3 URLs. Option B is incorrect too for the same reason. Option D is incorrect as with HTTPS, connections are encrypted between CloudFront and the users. However, it does not restrict access to the S3 files. You own a MySQL RDS instance in the US East 1 region. This is a multi-AZ instance, which means there is a standby instance in another availability zone. As business grows, more clients come from Europe, EU West U region, and most of the database workload is read-only. What is the proper way to reduce the load on the source RDS instance? The best way to reduce the workload is to use a read replica which can share the read workload of the source DB instance. Read replica can also be configured in a different AWS region, which perfectly fits what's asked in the question. Well, we just need a read-only database to reduce the load on the primary instance. Launching a completely new instance would not be a great idea. What's stated in option C is incorrect, as read replica can indeed be launched in another region. I will just summarize this question for you. There is a broadcasting network which is getting merged with a media firm. They both have multiple AWS accounts managed by AWS organizations. As an AWS consultant, you need to decide the best way to move the master account of the original media firm to the organization used by the merged entity. Select three options. Well, to move the master account from one organization to other organization, the following steps need to be implemented. First, remove all member accounts from the old organization. Next, delete the old organization. Finally, invite the old master account to join the new organization as a member account. Again, let me just sum up what's asked in this question. A firm uses AWS organization to manage its development and production accounts. The question is, how do you share resources of EC2 dedicated host from the production account to the development account? Well, for accounts that are part of AWS organization, if resource sharing is not enabled at the AWS organization level, resource sharing can be done at the individual account level. So resources are shared as external accounts, and an invitation needs to be shared between these accounts to begin resource sharing. Option B is incorrect because if sharing needs to be done between accounts in an AWS organization, then sharing needs to be enabled for the resources. Option D is incorrect, as removing a destination account from AWS organization is not required for resource sharing. A medical institute uses a legacy database for saving its patient details. Due to compatibility issues with the latest software, they plan to migrate this database to DynamoDB in AWS. As an AWS consultant, you need to ensure that all tables of the legacy database are migrated without any glitch. Which of the following is the most cost-effective way of transferring the data? All the options mention AWS DMS, which is nothing but a database migration service that helps you to migrate database to AWS. Here, we migrate from legacy to a NoSQL database DynamoDB. So this is a heterogeneous migration, as the source and the target have different database engines. For such heterogeneous migrations, which is well supported by AWS DMS, you would first use the schema conversion tool, which automatically converts the source database schema and a majority of the objects like views and stored procedures to a format compatible with the target database. This eliminates options B and C, as they suggest engine conversion tool instead of schema conversion tool, which I am not really sure if there is any such thing. Finally, before saving all the data to DynamoDB, using an S3 bucket as an intermediate data store is more cost effective than using the EC2 instance. So the correct choice is option A. A site saves all the data from on-premises to EFS as a redundancy plan. Its on-premises database is constantly updated. You need to ensure that all files saved at EFS using AWS Data Sync are validated for data integrity for each packet. Which of the following will ensure fast transfer of data between on-premises and EFS with data integrity done as per the security guidelines? AWS Data Sync performs integrity checks for each packet to ensure the data returned to the destination matches the data read from the source. Additionally, an optional verification check can be performed to compare source and destination at the end of data transfer. If the data is constantly changing, files at the source are slightly different from files at the destination. So you can disable verification during transfer and re-enable verification post data transfer and ensure that all data is correctly copied between on-premises servers and EFS. Doing the verification at the end will speed up data transfer too. So option C is the right choice. Option A is incorrect, as enabling data verification for a constantly changing database will lead to slow transfer of data. Option B is incorrect, as verification needs to be performed post data transfer to ensure all data is properly copied to EFS. Option D is incorrect, as disabling verification will not perform data integrity check on data transfer between on-premises servers and EFS. A team is working on a Rtmp-based Flash application. Well, Rtmp stands for Real-Time Messaging Protocol. They want to test this application with a few users spread across multiple locations. So they created an Rtmp distribution in CloudFront. You have to control access to the application so that only specific users from these locations can access the application during a specific time. Which of the following can meet this requirement? For Rtmp distribution, signed URLs can be used to control access to the private content. While creating signed URLs, start date and time and the IP address range of users who need to access Rtmp application is optional, while end date and time is required. So option C cannot be the right answer, as we cannot create a signed URL with only the start date and time and the IP address range. Option D is the right answer, as we need to specify end date and time while creating the signed URL. Options A and B are incorrect, as signed cookies do not support Rtmp distribution. Your team has developed an application in .NET and hosted it on an EC2 instance. It accesses a DynamoDB table which will be deployed to production. Which of the following is the ideal and most secure way for the application to access the table? As we discussed earlier, the correct way is to assign an IAM role to the EC2 instances so they get the necessary permissions to access the table. In fact, you should use roles whenever you want to delegate access to users or applications that do not normally have access to AWS resources. Storing the credentials in S3 or passing the credentials to the instance is not a good practice for applications in production. A company replicates infrastructure in multiple environments since the priority is to achieve as much automation as required. Which of the following components would help them achieve this purpose? The right answer to this question is AWS CloudFormation. If you are coming from the Azure world, CloudFormation is the equivalent of Azure Resource Manager template. CloudFormation is declarative, which means you just declare the resources you need, and CloudFormation makes sure to create those resources for you. It is an infrastructure build tool, and you can run the same template in multiple environments to replicate your infrastructure. AWS Elastic Beanstalk is for deploying and scaling web applications, so it's not relevant to the question. AWS Code Build is a continuous integration service, and Code Deploy automates software deployments to a variety of compute services. So they are more on the side of release and deployment and not for standing up infrastructure. A company has a set of EC2 instances that store critical data on EBS volumes. The security team has mandated that the data on the disk needs to be encrypted. Which of the following can be used to achieve this purpose? AWS Key Management Service enables you to create and manage keys for encrypting and decrypting data. So you can store the keys in AWS KMS and use them for encrypting critical data on EBS volumes. AWS KMS is the right choice. Option B is incorrect, as AWS Certificate Manager is used to generate SSL certificates to encrypt traffic in transit, but they cannot be used to encrypt data at rest. Option C is incorrect, as it is used for issuing tokens while using API gateway for traffic in transit. Option D is incorrect, as IAM access key is used to secure access to EC2 instances. A company has a set of EC2 instances that store critical data on EBS volumes. There is a fear that if data on the EBS volumes is lost, it could result in a lot of effort to recover the data from other sources. Which of the following would help alleviate this concern in an economical way? Option B is incorrect, because EBS volumes can still be lost even after encryption. You can create a script to copy data to an EC2 instance store, but the instance store itself provides just a temporary block level storage, so it's incorrect. The correct answer would be to back up the data on your EBS volumes to S3 by taking point-in-time snapshots. This solution is efficient because snapshots are just incremental backups, which means that only the blocks that have changed after your more recent snapshot are saved. Option D is incorrect, since mirroring data across EBS volumes is inefficient when you already have an option for taking EBS snapshots. Coming to the last question, a team plans to host data on AWS. Following are the key requirements. the ability to store data as JSON documents, and high availability and durability. Select the best schemaless storage that you would use. Amazon EFS is a file storage for use with compute instances on the AWS cloud. So it's not really suitable for the question. Amazon Redshift is a fully managed data warehousing service in the cloud. Although Amazon EFS and Redshift provide high availability and durability, they are not suitable for schema-less storage mechanism. CloudFormation is not really a storage service, but rather helps you to define, create, and manage your infrastructure in the AWS. So that leaves us with DynamoDB, which is a fully managed NoSQL database service. It doesn't require any schema, and the data in DynamoDB is stored in JSON format and hence is the perfect option for the requirement in question. Once you're done, submit the test and you can verify your performance from the result. Also, you get the performance report domain-wise, so you can analyze the questions for any particular domain and you will see all the questions related to that domain, their correct answers and explanations for each question, and also links to the AWS documentation in case you like to learn the concept in depth. So if you're thinking about clearing the AWS Certified Solutions Architect Associate exam, check the description for the link to entire practice test that cover the length and breadth of all the objectives in the exam. Also, please comment if you would like me to do this sample test for any other AWS certification, and do subscribe, share and like the video.